Welcome back to another video, another lesson on sigma notation. And this concept basically will wrap up whatever we have learned so far when it comes to series, right? So I'm just going to write it over here. So I must first recap what we know so far. So for series, we know that series is just a sum of the terms in a sequence. And then there are two types of sequences. You have your arithmetic progression and your geometric progression. Right, so from here you have things like your AP and your GP, but then you also have your other types of sequences. They are not necessarily considered an AP or a GP, right? So when it comes to series, it's not just limited to AP or GP. It can be many different type of sequences. So the question then comes, right? How do we generalize the representation of all these different series, right? Different types of series. That's the idea behind sigma notation. So we have sigma notation because we want to generalize how we actually represent a series. Because AP has its own way of representation, GP has its own way of representation, and when it comes to series, we want a more general way of just showing the different series. So how exactly, do we do that? That's the question over here. So I'm just going to write down an example of a general term for three different type of sequences. So let's say for an AP, I have something like 2 plus n minus 1 times 3. Right, this is an example. Now, for GP over here, right, I might have something like 2 times 3 to the power of n minus 1, right? Other type of sequences, maybe I have something that is, let's say, I have n squared, something like that, right, n squared. So you can see that this one over here is a general term of an AP, right? You have a starting number, and then you have a constant difference that you add to it. Now, the second one over here is that you have a starting number, and then you have a constant ratio that you multiply to this number. Right, and then the last case over here, n squared, it's not really considered an AP or a GP because, if I were to write out T1, T2, T3, for instance, this will be 1 square, 2 square, 3 squares, right? So the series for this would be the sum of squares, which is neither an AP or a GP, just to give you an example. So if I were to explicitly state the T1, T2, T3 for all of this, right? Now, this one over here, it will be 2 plus 1 times 3, right? 2 plus 2 minus 1 times 3, 2 plus 3 minus 1 times 3. Now over here, this will be 1 minus 1, 2 minus 1, 3 minus 1, right? So you can see that different series have different general terms, and different general terms means that the terms look different. But what's a generalized way of expressing the series of all of this? It will be down to sigma notation. So we know that, okay, formula-wise, right, based on what we know, for an AP, Sn is n over 2 bracket 2a plus n minus 1 d over here, right? Or it could be n over 2 bracket a plus the last term, right? For GP, the Sn would be a bracket 1 minus rn, 1 minus r, right? Or you can write it in the other way, which is a bracket rn minus 1, r minus 1, right? So if we want to generalize the way that we actually represent this two, it will be in this thing called the sigma notation. So sigma notation has this symbol over here. I'm just going to write here. It's a symbol that basically represents the sum of. Okay, we call this the sum of. Now, in a sigma notation, the symbol, we will need to initialize it. Okay, we will need to initialize it with a starting term. So let's say in this case, my starting term is n equals to 1. And then let's say I want to add it up all the way until n equals to 5. Okay, so let's say, I'm just going to write here. Let's say I want the sum of T1, T2, all the way until T5. So I will start at 1. Here is my starting value for n. And then over here, I'll write a 5. Now note that over here, we typically do not write n equals to 5. We just write 5 over there. But you can write n equals to 5 over there if you want, right? If it makes it clearer for you. So sometimes you realize that it's not really necessary to do that. And then over here, what comes next? This portion here is the general term. So Tn will be here. So our Tn is essentially 2 plus n minus 1 times 3, right? So in other words, right, this whole portion over here is basically your S5. Because we start from 1 and then we go all the way up until 5. Right, and then it's equivalent to S5, which is 5 over 2 bracket 2 times 2 plus 5 minus 1 times 3, right? So this is the idea behind it. Sigma notation is just another way for us to represent the sum of terms. So let's say if I want to find out what is the sum of the third term to the 7th term. Okay, so I just put another example over here. Let's say I want to find out what is the sum of term 3 to term 7. So you realize that sigma notation allows us to actually find the sum of term 3 to term 7 just by writing 3 over here and writing 7 over here, right? So what advantage does sigma notation actually have over the usual normal formula as you can see over here? Now, this usual formula that you see over here, the limitations of these two formulas, right? The limitation is that these two formulas must start from T1. So when I say S5, automatically is starting from T1, T2, T3, T4, T5. If I let's say S10, then immediately is I start from T1, T2, T3, T4, all the way until T10. Right, then sum them up together. But in some cases, we actually don't want the sum of T1, T2. For instance, let's say I want the sum of T3 to T7 only. We need to exclude T1 and T2 from S7. So how exactly do we represent this in sigma notation first? So sigma notation, we will express it as this, right? This is called the sum of what? The general term, right? 2 plus n minus 1 times 3. And then we start from n equals to 3 and we end up at 7. So this over here basically tells us we are looking for T3 plus T4 plus T5 plus T6 plus T7, right? We go all the way until T7. So how do we actually find out the value of this using the formula over here, right? This formula here. Because sigma notation is just a way for us to represent, represent summations, right? Represent series. So once we represent it in this way, in order to calculate the value, we must still use the formula that we have. And the way that we actually do that would be to break this down, right? So realize that if I want to add up until T7, T1, T2, T3, T4, T5, T6, T7. If I only want this, right? This is what I want. Can I take S7, which is this whole thing, and minus away S2, right? You realize that when I take S7 minus S2, I get what I want. And S7 is basically the sum of n equals to 1 all the way to n equals to 7. And then for S2, it's just the sum of all the terms from n equals to 1 all the way to n equals to 2, right? So this over here can be written as summation of 7, n equals to 1, 2 plus n minus 1 times 3, minus away 2 summation of n equals to 1, 2 plus n minus 1 times 3, right? Because this over here basically just tells us that, hey, I want the sum of the general term from n equals to 3 to n equals to 7. So essentially I'm saying that I want T3 plus T4 plus T5 plus T6 plus T7. But the thing is that in order for me to calculate this, I must use this formula over here. And in order for me to use this formula over here, the constraint of this formula is that everything will start from T1. So in my head now, I'm thinking, okay, since everything must start from T1, how can I manipulate this over here to allow me to start from T1? And that's where I realized that I can actually break this down into an equation, which is the sum of all the terms up until 7, so S7. Then I minus away S2. And the thing about S7 and S2 is that both of them start from T1. So this is basically what sigma notation is in a nutshell. It's just a way to represent the sum of the terms in a series. Whether it's AP, GP, or other type of sequences, you can basically use sigma notation for everything, right? As long as there's a general term in a sequence, right? And I introduced one very important property over here to you already. Now, in the whole entire landscape of sigma notation, right, as I will go through later on again, right? So I hope that, even if you don't understand what I'm saying right now, later on I will still go through these basic properties one more time, right? But I just bring this concept up to you first. So there are many different properties when it comes to sigma notation, but the most important thing now is just to make sure that you understand roughly what the idea is, right? So if you've got any questions, just let me know in the comments below. But as long as you just understand the rough idea of whatever I just said, then okay, you can proceed to try these practice questions out for yourself. But before you actually try this practice question, I would urge you to try and annotate all these different questions first. Annotate what each number and what each symbol means. And I'll pause this video to do that right now, because right now we are actually going to go through this question over here to make sure that you fully understand what sigma notation is and what the point of it is really. So, starting from the first part, right, they want us to write out the series explicitly. So over here, we are not solving anything yet. We are just asked to write out the series explicitly so that we really know what's going on. So looking at the first one over here, this is starting from the value of r equals to 1. And we are going up all the way until r equals to 5, right? So over here, we know that this is r equals to 5. So we are summing up the general term, which is r squared, from r equals to 1 all the way until r equals to 5. So this will mean that we are taking 1 square plus 2 square plus 3 square plus 4 square plus 5 square, right? And that's the answer over here, right? Because they want us to write out the series explicitly. So they are not asking us to find the sum. They're asking us to find the series, which is, inclusive of all the plus signs explicitly. So we are just supposed to figure out what are the members of the series over here. Okay, next. Over here, we start from r equals to 1 and we go all the way until r equals to n. So over here, this basically gives us a general term over here, right? As you can see. Now this general term over here, again, we are supposed to write it out explicitly. So we go from 1 over 1, right? Plus over 2 plus 3. Then we go all the way until n, right? So we plus dot 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 until we go all the way until n. Now notice something, right? Notice that whenever the power here is odd, right? The entire value will be negative. But notice whenever the power over here is even, the whole thing over here will be positive. So that gives us -1 plus half minus 1/3, right? And then of course you can repeat. So you have 1/4, right? Minus 1 over 5th. And then you go all the way until -1 to the power of n over n. And that's the final answer to this portion over here. Now we cannot conclude whether n is odd or even, right? So we'll just leave it in its general form over here will do. Okay, so that is the answer to C. Now on to B. This one over here, again, is just writing out your answers explicitly, so we don't really need to sum up anything yet. But the idea behind this is that we start from r equals to 2, and we go all the way until r equals to 6. So over here, we'll get 3 times 2 minus 2, 3 times 2 plus 1. This is our first term. And then from the first term here, we're going to add the second term, which is 3 times 3 minus 2, 3 times 3 plus 1. Then after that, we plus. Then now we add the fourth term. So 4 minus 2, 3, 4 plus 1. Then now we add the fifth term. So 5 minus 2, 5 plus 1, right? And then last but not least, we add the sixth term. So 6 minus 2, 6 plus 1. And then of course, you can further simplify this to just like combine these two terms, combine the expansion within the bracket itself. And that will give you 4 times 7 plus 7 times 10 plus 10 times 13 plus 13 times 16 plus 16 times 19, right? So then, of course, they want us to write it explicitly, so we don't really expand it yet. Okay, and then last but not least, this one is slightly more interesting. We have r equals to 0, and we go all the way until r equals to n. Now, notice that for the general term over here, there is no r. So what does this mean for us, right? So for part D over here, I'm just going to write the answer below here. What this means is that we are essentially taking 2 plus 2 plus 2 plus 2 plus dot 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 plus 2. This one is when r equals to 0. This one is when r equals to 1. This is when r equals to 2. This is when r equals to 3. And then this is when r equals to n. So in total, we actually add 2, right? n plus 1 number of times. And just a shortcut for you, for example, or just a hack for you, to calculate the total number of terms, right? Total number of terms is always n minus n plus 1. Which means that in a summation like that, this is m, this is n, you will take m minus the n plus 1 at the end. Because we need to plus 1 to account for the term inclusive of n. Because when we minus n away, we also minus the n portion. So we need to add it back. So in this case, we take n minus 0 plus 1 to give us n plus 1 number of times, right? So we add 2 n plus 1 number of times. So we can simplify this to give us n plus 1 times 2, right? So yeah, that's basically what we can further simplify this to get, but honestly, if you wrote this, you'll be fine. Now, this is not an exam type of question, right? It's just so to help you understand what sigma notation is before we actually go into the more difficult or slightly more complicated questions. Okay, so feel free to pause this video now to consolidate your thoughts. If not, we'll try moving on to the next question right now. So once again, please pause this video to try this question out. This is the reverse of the before. Before we get the sigma notation, then we write out the terms. Now we got the terms, then we write the sigma notation. Okay, but it's actually very simple. So I'll pause this video to try it out, and I'll go through the questions right now. Alright, so let's look at this. Now, we are given a series here, and we can see that this is an AP, right? Because here to here you plus 2, here to here you plus 2. And the thing is that over here, this is actually already the general term, right? General term. Whereby, we know it's 1 plus n minus 1 times 2 over here, right? But then, of course, if you expand this, then you'll get like this. So, whenever we want to write it out in sigma notation. The question that we need to ask ourselves is, what value of n do we start at? So over here, we know that n equals to 1, n equals to 2, n equals to 3, right? Because this is t1, t2, t3, and so on and so forth. So my value n over here will have a value of 1. And then I go all the way until here, because this is the general term tn. So this is quite literally n equals to n, right? Because we stop at tn. And then the general term over here, we can just copy this, and that will be 2n minus 1 as the final answer to this question over here. So you don't need to write the n equals to on top, it's automatically taken that is there. Okay, now for part B over here, this one, you can see that there's a slight trend, right? If this is n equals to 3, n equals to 4, n equals to 5, and then this goes all the way until n equals to 55. So the pattern is that the variable is actually the number over here, while the square outside is the constant. So I know that the general term, right, the general term for this would be n squared. But then my n value does not start from 1, because we can see that the smallest value over here is 3, and the largest value over here is 55. And therefore, the sigma notation for this will be n equals to 3. It goes all the way up until 55, and then this is n squared. So you can either write it this way, or the answers provide another way, which is also very possible. You can also write it in this way as well, if you saw it the other way around, but will give you the same answer. So you can either see it as an AP or just n squared, right? Because another way of looking at this would be viewing this as an AP, which is you start from 3, then plus n minus 1 of 1, right? Then this will be t1, t2, t3, so on and so forth, right? And then the second term would be 3 plus 2 minus 1 times 1. Then that will give you 4, right? Then you go all the way up until 55. So there are many ways of seeing this, and there's no right answer to it. So, feel free to leave whatever you think makes the most sense to you. So that is the answer for this portion over here. Now, the last one, part C over here. For part C, we actually need to pay attention to the symbols, right? The symbols. So you can see that for the symbol over here, what's special about this is that the sign actually alternates, right? Positive, negative, and then it keeps repeating and repeating and repeating and repeating. So for part C over here, right, we know that if this is term 1, term 2, term 3, term 4, we know that over here, this is negative, negative. But then that kind of contradicts what we know so far, right? Because we know that whenever we square anything, right, when we want to square something, the value that comes out will always be positive, right? Same thing whenever we raise anything to the power of 4, the term that comes out will always be positive. So this kind of contradicts what we know. So instead of naming this as T1, T2, T3, T4, how about we start from T0, right? So if this is T0, T1, T2, T3, you realize that when this is an odd number, then it makes more sense for this to come out to be a negative, right? And if this starts from T0 and it goes all the way up until infinity, we could technically say that this starts from 0 and it goes all the way up until infinity, right? So it's completely fine to just write the infinite symbol over there, right? And then, of course, what is our general term? So our general term is actually negative x raised to the power of n. Because if you realize that 1 over here is essentially negative x to the power of 0, which gives me 1. Right? Negative x to the power of 1 gives me negative x. Negative x to the power of 2 gives me x squared, which is what we have over there, and it's positive. And then negative x cubed gives us negative x cubed over here. Right? So the general term is actually this. And this is all done through just pure observation. Right? So, yeah, these are the 2 introduction questions to sigma notation. I hope that this video was made sense to you. Any questions, leave it in the comments below. And if you'd like to check out more of this style of videos and get my full library access to all of the questions that I go through just like that are exam level kind of standard, make sure to click the link in the bio to see how you get access to those courses. If not, I'll see you in the next video to talk more about the basic properties of sigma notation.